Hi guys, I'm Thomas Fernandez and this is Ignix. And in today's video, we're going to learn about a few basic operations on complex numbers. So without further wasting time, let's get started. So before we start with complex numbers, there's something important I'd like to tell you about. Yes, more than 80% of the people in the world don't know what complex numbers are. They don't know how to operate in complex numbers. Yet, they're doing still fine in life. So, why do you need to learn complex numbers? Well, the answer to this is very simple. Complex numbers and maths is much more than what you solve in your books and also the applications of the formulas at your work. Complex numbers and maths are about developing a mindset of solving problems, understanding how problems work and how you need to solve them. Let's take for example the root of minus 1. Well, the root of minus 1 after we know complex numbers seems very simple. But this very simple root over minus 1 had troubled mathematicians, great mathematicians, for over centuries. It took centuries till someone used their imagination and looked beyond the obvious set of real numbers to find out the value of I as root over minus 1. This imagination is what is needed to solve a lot of problems irrespective of if you know complex numbers or not. So on this note, let's use our imaginations and develop a sense of understanding for solving problems by learning a few operations on complex numbers. In the last video, we learned that complex numbers are numbers of the form a plus ib, where a and b are real numbers and I is the imaginary unit. Also, the number can be divided into two parts, where a is the real part of the number and ib or bi is the imaginary part. If you look carefully at complex numbers, a and b are real numbers, so they can take up any real number value, be it negative, positive fractions or even 0. So let me try something interesting here. Let me take the value of a or b or even both a and b as 0 and see what all numbers do we get. So let me first take a equal to 0. If a is equal to 0, you'll notice that the real part of a becomes 0 and what we are left is only with the imaginary part. Such a number is known as a purely imaginary number or a purely imaginary complex number. Now, if I put b equal to 0, what I'll be left with is only a real part a and the imaginary part will become 0. Such a number is called a purely real complex number or a purely real number. Now let me try putting both a and b equal to 0. Well, if I put a and b both equal to 0, what I'll get is the real part also becomes 0 and the imaginary part also becomes 0. This is nothing but your number 0. So if you look at this, the complex numbers themselves can be divided into three parts. A purely real complex number, a purely imaginary complex number, or just a complex number. In the last video, we had taken the equation x square plus 1 equal to 0 to get the value of x as root over minus 1. But what if I had x square plus 5 equals 0? Yes, what would I get here? I will get x is equal to root over minus 5. Now if I look at root over minus 5, what I can do is I can write it as root over 5 into root over minus 1. It will give me still root over minus 5. Now I know the value of root over minus 1. I can write it down as I. So what I'll be left with is a root over 5 into I. This is nothing but root over 5i. So if you have a look, I is the imaginary unit, and if I is multiplied with any number, it can turn the number into a complex or an imaginary number. This imaginary unit helps us reduce the squares of some very big negative numbers to simplified forms of a number into I. The number can be as simple as a whole number or a natural number or even a surd. So let me show you some examples here. Root over minus 25 can be written as root over 25 into root over minus 1. Now if I take the square root of root over 25, what I get is 5 and root over minus 5 becomes I. So what I'll get is root over minus 25 is equal to 5i. Now if I take root over minus 7, what I'll get is root over 7 into root over minus y, which will give me root over 7i. So if you have a look at this, this is again of the form a plus ib, where a in this case is 0 and b is equal to root over 7. Or in the case of root over minus 25, a was equal to 0 and b was equal to 5. These are just some simple ways of converting square roots of some really huge negative numbers to simplified forms of complex numbers. Now that we know this, let's take it a notch higher and see how do we add and subtract complex numbers. Before we add or subtract complex numbers, let's just work on a simple polynomial. Let me take 2x plus 3 and 3x plus 4. So, whenever we add 2x plus 3 and 3x plus 4 or such polynomials, what we do is we add the coefficients of the variables together and the constants together and write them separately in the same form. So in this case, what we'll do is we'll add 2x plus 3x, which will become 5x. We put the plus sign and then we add the constants 3 plus 4, which will give me 7. Pretty simple. So what we have is 5x plus 7. Similarly, we can subtract 2x plus 3 minus 3x plus 4. While subtracting a polynomial from another polynomial, we have to make sure that we change the signs of the second polynomial. So in this case, since 3x plus 4 is the second polynomial, I'll change the signs of 3x plus 4. So plus 3x becomes minus 3x and plus 4 becomes minus 4. Now what we do is we again do the same thing as we did in case of adding. We take the coefficients of the variables together, so it becomes 2x minus 3x. So 2 minus 3 will give me minus 1, which I can also write as minus x. Now we look at the constants. Plus 3 minus 4, it will again give me minus 1. So what we'll have here is, we'll have minus x minus 1 as the answer. I know that many of you might have done addition and subtraction of polynomials a lot of times. But the only reason I'm doing it again here is because addition and subtraction of polynomials and the addition and subtraction of complex numbers are very similar in nature. In case of addition and subtraction of complex numbers, we follow a very similar pattern. We add the real parts together and the imaginary parts together and write them separate as real and imaginary parts again. Let me show you some examples of complex addition and subtraction as well. I'll take the same example of 2x plus 3 and 3x plus 4, but in this case I'll take them as complex numbers. So what I'll have here is, I'll have 2 plus 3i and 3 plus 4i. So in this case, I'll add the real parts together. So I'll add the real parts 2 plus 3, which will give me 5. Now what I'll do is, I'll add the imaginary parts 3i plus 4i, which will together give me 7i. So just like polynomials, we do not add i's here. So the sum of these two complex numbers is 5 plus 7i. Isn't the answer very similar to what we got in case of polynomials? So let me try subtraction now with the same numbers. Let me try 2 plus 3i minus 3 plus 4i. Again, just like polynomials, the first thing that I'll do is I'll change the sign of the second complex number. So plus 3 plus 4i becomes minus 3 minus 4i. So now we equate the real and imaginary parts of the complex numbers separately. So what we get is 2 minus 3 will give me minus 1. Now if I subtract plus 3i minus 4i, what I'll get is minus I. So the difference of the two complex numbers in this case is minus 1 minus I. It's very simple. So now let me show you something interesting. Let me subtract 1 plus 3i from 2 plus 3i. When we subtract the real parts, we get 1. And when we subtract the imaginary parts, in this case, 3i minus 3i, we get 0i. This is nothing but a real number. So if you have a look, when we add or subtract two complex numbers, there are possibilities that we may also get real numbers. That the sum and difference of complex numbers may or may not be always complex numbers. Addition and subtraction are the most basic operations that we do on complex numbers. There are more operations like multiplication, division, and even exponents. Yes, you can find out the square roots of complex numbers, even higher roots of complex numbers. But this we are going to do at a later stage, because not everyone of you requires to learn multiplication, division, and even exponential operations on complex numbers. So for now, we'll end complex numbers here and restart it at a later time. And for the next video, I'll force you to make a move. Well, is that a hint? I don't know. To find out what you can do is follow our page InkNext on Instagram to get updates on what our content will be and also to find tips and tricks videos on it. Also, if you like our content, do like it and share it with others. Also, if you have any doubts, you can mention it in the comments. I'll be really happy to help you. And don't forget to subscribe and click on the bell icon because if you don't click on the bell icon, you're missing out on education. Thank you.